Hi, this lesson is on antiderivatives. So the prefix anti means not or the opposite. So antiderivative is pretty much the opposite of the derivative. So when the process of finding the antiderivative is called antidifferentiation. So if we call a function capital F the antiderivative, then the derivative of the antiderivative is equal to the original function. So let's look at some specific antiderivatives here. So if the function f of x plus c is considered to be the general antiderivative, so what's c? We're going to call c just some arbitrary constant, and it is actually called the constant of integration. And it's a little early for us to talk about integration, but this is the beginning of that topic. It's called the constant of integration. So if capital F of x plus c is the general antiderivative, and that's true only if capital F prime of x equals little f of x. And remember, if you take the derivative of c, that just equals 0. So let's look at this from the perspective of trigonometry. So if you have a function f of x, then we call its antiderivative here on the right. So if f of x is equal to sine of x, then the antiderivative is negative cosine of x plus c. So let's look at this more carefully. If this is true, then f prime of x must equal f of x, which is actually true. So if you take the derivative of negative cosine of x plus c, that should equal the original function sine. So what's the derivative of negative cosine? Well, the derivative of cosine is sine. The derivative of cosine is negative cosine, so that negative in front makes it a positive sign, and the derivative of c is 0, so the left side equals the right side. So that's always a quick way for you to check if your work is correct. So similarly, the antiderivative of cosine is sine of x plus c. The antiderivative of cosine of x cotangent of x is negative cosecant of x plus c. Derivative of secant of x tangent of x is secant of x plus c. The derivative of the antiderivative of secant squared is tangent of x plus c. And the antiderivative of cosecant squared of x is negative cotangent of x plus c. So all of those derivative rules that you learned in the past, you're basically looking at it from the opposite direction with antiderivatives. So one of the most important rules with antiderivatives is this one that we call the anti-power rule. So it is the opposite of power rule that we used for derivatives. So if your function little f of x is equal to x to the n, and so keep in mind, n could be any real number except negative 1. Then the antiderivative of f of x equal to x to the n, well, that's 1 over n plus 1 times x to the n plus 1. So what happens from the original function to its antiderivative is that you add 1 to the exponent, and then you multiply by the reciprocal of that exponent. So here's an example. If we have a general antiderivative, we want to find the general antiderivative of x cubed. So x cubed is f of x. So if f of x is equal to x cubed, then our antiderivative, capital F, will be the exponent raised by adding 1 to the power, and then multiplying by the reciprocal of that exponent. So that's 1/4, and then you need to add your constant of integration. So that's what you see here as your antiderivative. And just as I explained before, if you were to check this, your check, and you should probably do checks until you get more comfortable with this, check if f prime, capital F prime of x equals f of x. And in this case, it does. So you know that your work here is correct. Similar similar rule here, the next bullet point, is if f of x is equal to k x to the n, where k is a constant, and remember, n cannot equal -1, then you're still applying your anti-power rule. Right here, you add 1 to the exponent and multiply by the reciprocal, and k just gets multiplied by that whole antiderivative. So you get k over n plus 1, x to the n plus 1. So an example is here below. If we let f of x equal 9 square root of x, which is x to the 1/2, then your antiderivative, capital F, well, the 9 is just going to come along with whatever you do in terms of the rule. So you have to add 1 to the exponent. So 1/2 plus 1 is 3/2, and multiply by the reciprocal of that fraction. So you have to add 1 to the exponent first before you multiply by the reciprocal of that new exponent, and then plus c. And when you simplify, you get 6x to the 3/2 plus c. Okay, so sometimes you have rational expressions or products of expressions. We do not have an anti-quotient rule. We do not have an anti-product rule. So in order for us to be able to apply the anti-power rule that we just discussed above, you're going to have to rewrite the expression in a different way. So for example, in example 3, x minus 5 over the square root of x. If you divide x minus 5 by square root of x, you end up with two individual terms, x to the -1/2 and 5x to the -1/2. And then at that point, you can apply anti-power rule to each of those individual terms, and you get this result here. This is your antiderivative. And again, don't forget that constant, to add the constant when you're looking for a general antiderivative. Similarly, if you have a product of expressions, you want to separate them out into individual terms. So when you distribute here square root of x across these two terms, you end up with a function x to the 3/2 minus 3x to the 1/2. Now that's something that you can apply the anti-power rule to. So you add 1 to the exponent of 3/2, so you get x to the 5/2, and then multiply by the reciprocal, which is 2/5. Then you add 1 to the second exponent, so 1/2 plus 1 becomes x to the 3/2, multiply by 2/3, but that cancels with the 2/3, the 3 cancels with this 3 right here, and so you have 2/5 x to the 5/2 minus 2x to the 3/2, and again, add your constant. Okay, so let's do some other examples. Oh, one more rule, sorry. The general antiderivative of e to the x is just e to the x plus c. So if you remember, the derivative of e to the x is e to the x, therefore the antiderivative of e to the x is also e to the x. All right, so we're going to apply all of these, anti-power rule, the e to the x, some of the trigonometry in the following examples. So we want to find the general antiderivative for each of the following. So little f of x is 4 square root of x minus 2 e to the x plus 5. All right, so first thing you want to do is rewrite the radical. So it's written as 4x to the 1/2 minus 2e to the x plus 5. So now I'm taking the antiderivative, and I'm calling my antiderivative the capital, the corresponding capital letter here. So I'm calling it capital F of x. So here you have to add 1 to the exponent. So 1/2 plus 1 gives me 3/2. Then multiply that by the reciprocal, which is 2/3. So your first term is 4 times 2/3 x to the 3/2. The antiderivative of e to the x is just itself. So when you multiply it by 2, it's still minus 2 e to the x. Second term is the same. And then antiderivative of 5. Remember, you're going backwards. So the derivative of 5 would be 0, but the antiderivative of 5 is 5x. So when you have a constant and you're looking for the antiderivative, you're just attaching the variable to the constant. And then again, followed by your by your arbitrary constant or your constant of integration. Right, so the last step is just to multiply the first term. So 4 times 2/3 becomes 8/3, and the entire antiderivative is found here. And as I stated before, if you take the derivative of capital F prime, it should equal the little f of x that we started with. All right, so here's another one with some trigonometry. So I have g of t equals 8 sine of t minus 3 secant squared of t. And again, we're looking for the general antiderivative. So I'm using a capital G of t to indicate that it's the antiderivative. So the antiderivative of sine is negative cosine because the derivative of cosine is negative sine. My sine is positive, so in order for it to become positive, I have to put a negative here in front. So I get negative 8 cosine of t minus 3 tan of t, because the derivative of tan is secant squared. Therefore, the antiderivative of secant squared is tangent. And then plus c. And so let's actually check this one. Our check is check if g prime of t equals little g of t. All right, so the derivative of negative 8 cosine of t, well, that's going to be negative 8 times negative sine of t minus 3 secant squared of t. And two negatives make a positive, so 8 sine of t minus 3 secant squared of t. Well, that is the original function, so it checks out. All right, here's another one. I have a product. I'm calling it little h of x equals x squared plus 2 times 3x minus 1. So as I mentioned before, there's no anti-product rule. So we're going to first expand this or FOIL it so that we have individual terms. So the first term, this is still little h of x. First term is 3x cubed. Outer term is negative x squared. Inner term is 6x. And the last term is minus 2. Then we take the antiderivative. So here we're just using anti-power rule and the rule for the antiderivative of a constant. So capital H of x is 3 times 1/4 x to the 4th minus 1/3 x cubed plus 6 times 1/2 x squared minus 2x plus c. In the last line, we're just multiplying or simplifying fractions. So your final answer is that your antiderivative is 3/4 x to the 4th minus 1/3 x cubed plus 3x squared minus 2x plus c. All right, so here we have another one. It's again a quotient of two expressions. My denominator has a radical. So again, you need to separate this out into individual terms where your variable is just raised to an exponent or just a constant so that you can use your anti-power rule. So in this line, I'm just showing that little f of t is just the denominator is below each of the terms, and I rewrote the radical as t to the 1/2. Then in the next line, I use the rule for monomials. Remember, your rule for monomials says that if you have an expression raised to a power divided by another expression raised to a power, well, then you can subtract the exponents. So in this line that I indicated here with the arrow, I'm subtracting the exponents. So 2 minus 1/2 gives us t to the 3/2. The t over t to the 1/2, well, that's 1 minus 1/2. That leaves us with t to the 1/2. And in this case, I didn't have to subtract exponents, but you need that variable in the numerator. So I just rewrote it as 1/2 t to the negative 1/2. So the coefficients stay in the same position. So everything should be multiplied by 1/2. Okay. So now I'm taking the antiderivative. That's indicated here by the capital F. You add 1 to the exponent of each of your exponential expressions and then multiply by the reciprocal. So 3/2 plus 1 gives me 2/5, and the reciprocal of, 3/2 plus 1 gives me 5/2, and the reciprocal is 2/5. That 2/5 gets multiplied by 1/2. You do the same thing for the other two terms. So here the second term is minus 1/2 times 2/3 t to the 3/2, and then plus 1/2 times 2t to the 1/2 plus your constant. So from the second to last line to the last line here, you're just simplifying the fractions. So the 1/2 and the 2/5, the 2's cancel. You have 1/5 t to the 5/2. Again, the next one, 2's will cancel. So you get minus 1/3 t to the 3/2. And then here the 1/2 and the 2 cancels. So you get t to the 1/2 plus c. Okay, here if you checked if f prime of t equals f of t, you wouldn't exactly get back to where you started because we did some simplification. But if you did check it, it would look like this line right here. Okay, so this is just a reminder that the general antiderivative of f prime is f of x plus c. So it's just slightly different notation. So if the derivative of f is f prime, then the antiderivative of f prime is f. So instead of using little f and capital F like I did above, I'm just going to be using different notation. Okay, so we want to find the general antiderivative for each of the following. So suppose f prime of x equals -3 cosine of x plus cosecant of x cotangent of x. We want to find the general antiderivative. So the antiderivative of f prime is f of x. So the antiderivative of -3 cosine of x, well, that's -3 sine of x. The antiderivative of cosecant cotangent, well, that's minus cosecant, whoops, these are flipped, cosecant of x, and then plus c. Similar to what I explained before, if you take the derivative of your answer, if you take the derivative of what you got, it should equal what you started with, which makes sense. Okay, here we have another. I have g prime of x equals a cube root of x plus b over x squared. A and b are just numbers, coefficients of these two variable expressions. So the first thing I have to do is rewrite those terms in a way so that I can use anti-power rule, which means it should be x raised to a power, not a radical and not in the denominator the way the original expression is stated. So that becomes g prime of x is ax to the 1/3 plus bx to the -2. Then you take the antiderivative of both terms. So that's anti-power rule. So if you add 1 to a third, you get 4/3 and multiply by the reciprocal. That's why you have 3a times 3/4. Here you do the same thing, add 1 to -2, so you get x to the -1. The reciprocal of -1 is just -1, so you have b times -1, and then plus c. So when you put it all together, you get that g of x is 3a over 4, x to the 4/3, minus b over x plus c. Okay, so let's do another. On the left here, we want to find f of t given that f double prime of t is equal to sine of t minus t squared. So this time I've given you the second derivative and we need to find the original function. So that means I'm going to have to take the antiderivative twice. So here, from this line to this line, I've taken the antiderivative. So the antiderivative of f double prime is f prime. So that's negative cosine of t minus 1/3 t cubed plus c. Then you have to take the antiderivative of f prime to get f. So I'm here. The antiderivative of negative cosine of t is negative sine of t minus 1/3 times 1/4 t to the 4th. Remember, c is a constant, so the antiderivative of a constant, you just attach a variable to it, so we get ct. But then there's another constant because we've taken the antiderivative again. We want to distinguish one from the other, so I'm going to call it d. Okay, so your final answer is what you see here in the box. All I did was multiply the two fractions there in the middle. So f of t is equal to negative sine of t minus 1/12 t to the fourth plus ct plus d. And in order to check this, you would have to take the second derivative of your answer to get back to the original function. Okay, here's another one on the right. This one is regarding e to the x. So we want to find f of x given that f triple prime is equal to e to the x. So this time you have to take the antiderivative 3 times. So the antiderivative of f triple prime is f double prime, which you see right here. So f double prime of x is e to the x plus c. Remember, the antiderivative of e to the x is just itself. Then you have to take a derivative of f double prime to get f prime. So that's e to the x plus cx plus d. Okay, then we have to take the antiderivative of f prime to end with f, which is what you were asked for. So the antiderivative of e to the x is e to the x. Remember, c is the coefficient of x. So when you do anti-power rule to the second term here, you add 1 to the exponent, multiply by the reciprocal. So that's why you get 1/2 of c, or c over 2, x squared. The antiderivative of d is dx. And then again, you have to add one more constant of integration. So that will be e. So leaving you with e to the x plus c over 2x squared plus dx plus e. Okay. This next part, these are considered to be initial value problems. So with initial value problems, you can actually solve for c. You can find the c value, or the constant, of an antiderivative if you're given some information about initial value. So here's an example here. If f prime of x equals 10 t to the 3/2 and f of 1 is equal to negative 3, then you can find f of x. You can actually solve for what the actual function is by taking the antiderivative, the general antiderivative, which we get here, right? We did anti-power rule plus c. But then we solve for c by plugging in the information that was given. That's considered to be the initial value information. So what that means is that you plug in 1 for t, and we let the function equal negative 3, which you see here. So we have 4 times 1 to the 5/2 plus c equals negative 3. So 1 to the 5/2 is just 1. So this is 4 plus c equals c. If you subtract 4 from both sides, you get that c is equal to negative 7. So the actual function is what you see here, 4t to the 5/2 minus 7. Okay. And then this next part below, this is a reminder of things that we've talked about before, but this time we're going in the other direction. The relationship between displacement, velocity, and acceleration. So remember, we usually call displacement s of t, velocity v of t, and acceleration a of t. So the antiderivative of acceleration is velocity. The antiderivative of velocity is displacement. Okay. So we'll use that in a problem a little later. So here's an example of an initial value problem. Find f of x given that the initial value f of 0 equals 3 and that f prime of x equals 2 sine of x plus 5x squared plus 1. All right, so the antiderivative of f prime is what you see here. F of x is equal to negative 2 cosine of x plus 5/3 x cubed plus x plus c. Well, now is when we use the initial value information. You plug in 0 for x in your f of x function, and we set it equal to 3, as stated in the original problem. So we have negative 2 cosine of 0. Well, cosine of 0 is 1, so your first term is negative 2, which you see here. Then we have 5/3 0 cubed, well, that's 0, plus 0, because x is 0, and then plus c. So solving for c means you add 2 to both sides. You get that your constant is equal to 5. So the function is f of x equal to negative cosine of x plus 5/3 x cubed plus x plus 5. Okay, so let's do another. This is regarding displacement. So we want to find the displacement function s of t, given that v of t is equal to 3t squared minus 1, and that's in meters per second, and the initial value is that s of 0 is equal to 1. So remember, s of t is the antiderivative of v of t. So if I take the antiderivative of v, I get s of t here. So that's just anti-power rule. So it's 3 times, this is a times symbol here, it's 3 times 1/3 t to the third minus, and the antiderivative of 1 is t plus c. So if you simplify, the 3's cancel, and so s of t is t cubed minus t plus c. Well, now we can use the information that was given in the problem. S of 0 is 1. So you substitute 0 in for t, and you set the equation equal to 1. You get that your constant is 1. So the displacement function is t cubed minus t plus 1. Okay, here's another. We have a particle moving in a straight line that has an acceleration given by a of t equal to 6t plus 4. Its initial velocity is v of 0 equal to negative 6 centimeters per second, and its initial displacement is s of 0 equals 9 centimeters. And then we want to find the function s of t. All right, so the antiderivative of acceleration is velocity. So that's what we're doing here. We're taking the antiderivative. The antiderivative of 6t is 3t squared. Antiderivative of 4 is 4t plus c. Then you can plug in the information that's given. V of 0, that means plug in 0 for t, and we set it equal to negative 6. That's the information given in the problem. Then solve for the constant, you get that c is negative 6. So now you can use that information to come up with a new velocity function, replacing the c with negative 6. So v of t is equal to 3t squared plus 4t minus 6. But remember, we're looking for displacement. So we take the antiderivative of velocity to get your s of t. So again, anti-power rule, we get t cubed plus 2t squared minus 6t, and then we introduce a new variable, a new constant called d. So we have to solve for d by using the initial value information given in the problem. So s of 0 equals 9. Replace all of the t's with 0 and set it equal to 9. You find that d is equal to 9. So your displacement function is what you see here in the box. It's t cubed plus 2t squared minus 6t plus 9. Okay, here's another initial value problem. Find f of theta given that f double prime of theta equals sine of theta plus cosine theta. And you're also given that f of 0 equals 3 and f prime of 0 equals 4. Okay, so we're going to have to take the antiderivative twice. So f double prime, when you take the antiderivative, you get f prime. That's what you see here. So the antiderivative of sine is negative cosine. The antiderivative of cosine of theta is sine of theta, and then plus c. Then you can use this information given in the problem that f prime of 0 equals 4. So replace all of your thetas with 0. So we get negative cosine of 0 plus sine of 0 plus c equals 4. Cosine of theta is 1, and there's a negative in front, so that's why we have negative 1 plus 0 plus c equals 4. Solving for c, we get c is 5. So our new f prime is here. F prime of theta equals negative cosine of theta plus sine of theta plus 5. So now we're ready to take the antiderivative of f prime to get f. So we go from here to that line. Antiderivative of negative cosine is negative sine of theta. Antiderivative of sine is minus cosine of theta. Antiderivative of 5 is 5 theta, and then plus d. Again, we need to solve for d by using the initial value information. Remember, you're told that f of 0 is 3. We plug that in right here. So all of the thetas become 0. We set the equation equal to 3. So negative sine of 0, well, that's equal to 0. Minus cosine of 0, well, that's minus 1. 5 times 0 is 0 plus d. Solving for d means you have to add 1 to both sides. So you get d is equal to 4. So your final function is f of theta equals negative sine of theta minus cosine of theta plus 5 theta plus d. Plus, we just solved for this, plus 4. So now you're ready to try the homework for 4.9. Good luck.